Hey everyone, and welcome to another deep dive with us. Today we're going to be diving into the world of 20th century physics, and we're going to be looking at Edoardo Amaldi.
Sounds exciting.
It is going to be fascinating, I think, and we'll be guided by an essay by Jorgo Schneppat.
Okay.
And we'll be looking at how this remarkable figure, Edoardo Amaldi, not only made groundbreaking discoveries,
Right.
but really helped shape the landscape of modern science, especially after World War II.
Yeah, what I find really fascinating about Amaldi is how he was such a brilliant physicist, in the lab making discoveries, but he was also so influential in helping create institutions like CERN.
Right.
It really shows his commitment to, global scientific unity.
Yeah, for sure. So we've got Schneppat's essay here, and it really lays out Amaldi's journey, starting with his early work with Enrico Fermi.
Of course.
The famous Via Panisperna boys.
Right.
And it goes through their research on neutron physics, then his role in establishing CERN, and then how all of this work kind of laid the groundwork for the quantum technology we see today.
I mean, his life really does intersect with so many of the most pivotal moments in modern physics.
Yeah, it's really incredible. So to start unpacking all of this, let's rewind back to Amaldi's early life.
Okay.
He was born in 1908 in Italy to a family steeped in academia.
A real academic family.
Yeah, so it's no surprise that he developed a strong interest in science.
From a very young age.
From a very young age, yeah. His father, Ugo Amaldi, was a renowned mathematician.
Wow. So you can just imagine that kind of intellectually stimulating environment that he grew up in.
Oh, absolutely. I think that early exposure to academia must have been a major factor in shaping his path.
Yeah.
He ended up studying physics at the University of Rome, where he was mentored by, wait for it, the legendary Enrico Fermi.
Oh, wow. What an incredible opportunity that must have been. I mean,
Can you imagine?
Fermi was already making waves in theoretical physics.
At that time.
Yeah, at that time. So his mentorship had a huge influence on Amaldi, and it was during this period that Amaldi really dove deep into the emerging world of quantum mechanics, drawing inspiration from giants like Planck, Bohr, and Heisenberg.
It's like he was right there for the birth of a scientific revelation.
Absolutely. He was right in the thick of it.
Now, you can't talk about Amaldi without mentioning the Via Panisperna boys.
Oh, of course, this almost legendary group of young physicists.
Including Fermi, of course.
Right, including Fermi.
Who conducted just groundbreaking experiments that really shook the foundations of nuclear physics.
Yeah, their work was revolutionary, and one of their key discoveries was something called neutron slowing.
Okay.
And it's basically a process where neutrons lose energy by interacting with a medium.
So I'm trying to wrap my head around this. Why was neutron slowing such a big deal?
Well, imagine trying to harness the power of nuclear energy.
Okay.
To create a controlled chain reaction, you need those neutrons to slow down.
Got it.
So the research done by the Via Panisperna boys was crucial to understanding this process, which turned out to be a cornerstone not just for nuclear energy, but also for the later development of quantum physics.
Wow. So their research wasn't just some kind of abstract scientific pursuit.
No, not at all.
It had real-world implications right from the start.
Exactly. Their work on neutron slowing even laid the foundation for understanding nuclear fission, the process that powers nuclear reactors.
Okay, so we've got Amaldi in this really exciting period of scientific discovery, but then World War II happens.
Yeah.
Schneppat's essay talks about how Amaldi, unlike some colleagues who left for the United States to work on the Manhattan Project, chose to stay in Italy. What was behind that decision?
It seems like it was a decision deeply rooted in his principles. Amaldi was really against working on military technology, and instead he used this really turbulent period to kind of delve deeper into the theoretical aspects of nuclear and quantum physics.
So even in the middle of this global conflict, he was focusing on fundamental science.
It seems so, yeah.
That says a lot about his character.
It really does.
Yeah.
And this dedication to his research during the war, it would later prove to be invaluable as he took on the challenge of rebuilding science in post-war Europe.
Right after the war, Amaldi played a huge role in reviving Italian science.
Yes.
He focused on rebuilding institutions and encouraging scientists who had fled during the war to come back.
It was a monumental task.
Really a monumental task.
Yeah.
It wasn't just about rebuilding Italy, though, right?
Yeah.
It was about reintegrating the entire European scientific community.
Absolutely. It was a Herculean effort, but Amaldi really tackled it with amazing energy. One of his key achievements was the creation of the Italian National Institute for Nuclear Physics.
Right.
also known as INFN. This was really a critical step in putting Italy back on the map of global science.
So in a way, he was setting the stage for this whole new era of scientific collaboration.
Exactly, and that brings us to CERN.
CERN, Amaldi's role in its establishment was massive. I mean, it's just fascinating how this idea of fostering international scientific cooperation came about in a world so divided by the Cold War.
Yeah, I mean, Amaldi was one of the key architects of CERN, which was founded in 1954.
Right.
And it was a really bold vision, rebuilding European science, promoting international collaboration, and really using science as a bridge for peace.
That's such an inspiring goal.
It is, and it worked. CERN is a global center for groundbreaking research and a shining example of what happens when nations work together to explore the unknown.
Yeah, it's hard to overstate its importance.
It really is.
But let's dive a bit deeper into Amaldi's specific contributions to quantum mechanics and quantum technology.
Okay, so we've talked about his work on neutron physics and how that laid a foundation for quantum technology.
Right.
But he was also incredibly interested in kind of the more conceptual side of quantum mechanics, things like quantum coherence and entanglement.
Okay, those are some pretty complex concepts.
They are.
Before we go any further, could you give us just a quick breakdown of what quantum coherence and entanglement actually are?
Absolutely. So imagine you have this tiny quantum system, like an atom.
Yeah.
Quantum coherence is this mind-bending idea that this atom can actually exist in multiple states at the same time. It's like the atom is both here and there simultaneously.
Okay.
Entanglement, on the other hand, is a kind of spooky connection between two quantum systems.
Okay.
So their fates are linked no matter how far apart they are.
So we're talking about this weird and wonderful world of quantum mechanics.
Yeah.
Where things can be in two places at once and particles can be linked across vast distances.
Exactly. And these ideas, which might seem like science fiction, are at the core of a lot of quantum technologies.
So Amaldi wasn't just playing around with abstract concepts here.
No, not at all.
He was grappling with ideas that have huge implications for the technologies we're developing today.
Absolutely. Quantum coherence is crucial for building stable quantum computers. And entanglement underpins the security of quantum cryptography.
And to add to that, he was also a big supporter of experiments to test Bell's inequalities.
Yes.
Which helped to confirm the non-locality of quantum systems.
Exactly.
Wait, non-locality.
Yeah, it's the idea that these entangled particles can actually influence each other instantly, regardless of how far apart they are. It's one of the most mind-boggling aspects of quantum mechanics.
It really is.
And Amaldi's support for these experiments really helps solidify our understanding of this incredible phenomenon.
So Amaldi's contributions to neutron physics, combined with his deep dive into these mysteries of quantum mechanics, really set the stage for many of the advancements that we're seeing today.
Yeah, it's pretty amazing.
It is. But we can't forget his other crucial role as a mentor and a builder of scientific communities.
Right. Schneepatt describes him as this incredible teacher and mentor, a real shaper of future generations of physicists.
So what was his approach like?
Amaldi really believed in a strong theoretical foundation paired with practical skills. He wanted his students to be innovators with a deep understanding of the scientific process. He didn't just teach them physics. He instilled in them this passion for discovery.
It sounds like he had a real gift for nurturing scientific talent.
He really did. And he was equally passionate about building these international research networks. He saw them as vital for tackling grand scientific challenges, understanding that no one country could do it alone.
That brings us full circle to his work with CERN.
Yeah.
It seems like this collaborative spirit was a driving force throughout his career.
It truly was. And that leads us to perhaps the most impactful part of his legacy, how his work paved the way for the quantum world we're living in today.
So let's connect the dots.
Yeah.
How did his research on neutron physics and quantum mechanics actually lay the foundation for the advancements in quantum computing, cryptography, and sensors that we're seeing today? I'm really curious to hear more.
Well, let's start there in part 2.
Okay, sounds good.
Stay tuned. Welcome back.
We're back for part 2 of our deep dive into the life and work of Edoardo Amaldi.
And we left off talking about how Amaldi's work laid the foundation for so much of today's quantum technology.
Right. It's kind of amazing to think that research done decades ago is now driving such cutting-edge innovation.
Yeah, it really is.
So where do we see Amaldi's fingerprints most clearly in the quantum world?
Well, one area where his legacy really shines is in the world of quantum computing.
Okay.
And his work on neutron physics, especially his research on neutron slowing and nuclear reactors, was instrumental in understanding how to control quantum systems, which is really at the heart of quantum computing.
Okay. So we talked about how neutron slowing was key for harnessing nuclear energy.
Right.
But how does that connect to building quantum computers?
Well, the principles behind controlling nuclear reactions in a reactor are actually surprisingly similar to what's needed to control and manipulate quantum states for computation.
Oh, interesting.
So, Amaldi's deep understanding of these principles, which he honed through his work on nuclear physics, really provided a framework for scientists who are exploring the possibilities of quantum computing.
So it's not just about the specific technologies, but the fundamental principles that he helped uncover.
Exactly. His research helped us understand how to create that delicate balance needed to maintain the stability and coherence of quantum states.
Right.
Which is a huge challenge when you're trying to build a functional quantum computer.
Absolutely.
Yeah.
Now, quantum cryptography is another area that's captured a lot of attention lately.
Definitely.
And it relies on this mind-bending concept of entanglement. It's like having this pair of magic coins.
Mm-hmm.
You flip one and instantly, which way the other one landed, even if they're miles apart.
That's a great analogy.
And Amaldi's work, particularly, and his support for those experiments, testing Bell's inequalities, played a big role in confirming that entanglement was real.
It did. These experiments provided solid evidence that it wasn't just a theoretical idea, but a real phenomenon with potentially revolutionary applications like in cryptography.
So how does entanglement actually help make our communications more secure?
Well, imagine you and I want to share a secret message.
Okay.
Using entanglement, we can create a pair of linked particles.
Right.
One for you and one for me. And the incredible thing is that any measurement made on one particle instantly affects the state of the other, no matter how far apart they are.
Whoa.
And this lets us generate a secret key that's basically impossible for anyone else to intercept, making our communications super secure.
It's like having an unbreakable code based on the laws of physics.
Exactly. And it wouldn't be possible without a solid understanding of entanglement, which was really strengthened by Amaldi's work and his advocacy for experimental validation.
Now, the last area I want to touch on is quantum sensing.
Okay.
I've heard a lot about these super-sensitive quantum sensors being used to make incredibly precise measurements.
Yes.
So how does Amaldi's research fit into that picture?
Well, Amaldi's contributions to quantum sensing are more indirect, but equally important, I think. His work on understanding how neutrons interact with matter, how they scatter, how they lose energy, it provided insights that are now being used to develop these ultra-sensitive quantum sensors.
Could you give us some examples of that?
Sure. Think about atomic clocks, the most accurate timekeeping devices we have.
Right.
They rely on incredibly precise measurements of atomic transitions, which can be affected by even the tiniest environmental changes.
Oh, wow.
Amaldi's work on the interaction of particles with their surroundings laid the groundwork for understanding these really subtle influences, which allows us to build these super precise atomic clocks.
So his research is helping us measure time with this incredible accuracy.
It is. Are there other applications?
Yeah, are there?
Yeah, definitely quantum sensors are being used in everything from medical imaging to navigation systems.
Wow.
And even in the search for gravitational waves.
It's incredible how these quantum principles are being used to push the boundaries of what we can measure and detect.
It really is.
It seems like Amaldi's legacy extends far beyond just his own research projects.
I think so.
He was a visionary leader who shaped the scientific landscape, fostered global collaboration, and really paved the way for these technologies that are transforming our world.
I think that's a great way to put it. His story is a powerful reminder of the importance of scientific curiosity, striving for excellence, and working together to expand the boundaries of human knowledge. It makes you wonder what Amaldi would think of the quantum world we're living in today.
It really does.
Yep.
So what does this all mean for the future of quantum technology? What lessons can we take from Amaldi's approach as we navigate this exciting and rapidly evolving field?
That's a great question and a perfect segue to the final part of our deep dive.
Okay, great.
Let's explore that next.
And we're back for the final part of our deep dive into the life and legacy of Edoardo Amaldi.
It's been an incredible journey.
It really has. We've explored his groundbreaking work, his influence on modern science, and how his research paved the way for so many of these quantum technologies that are shaping our world today.
It really is amazing to see how it's all connected.
It is. So as we kind of look ahead to the future of quantum technology, what lessons can we draw from Amaldi's approach?
Well, I think Amaldi's story offers some valuable lessons for us.
Yeah.
One key takeaway is his unshakable belief in international scientific collaboration. He really understood that major scientific advancements require a global effort.
Yeah, his role in establishing CERN is a perfect example of that.
Right.
It's a shining example of what we can achieve when different nations come together and pool their resources and their expertise in the pursuit of scientific discovery.
And that spirit of collaboration is more vital than ever as we kind of push the boundaries of quantum technology.
Yeah, for sure.
I mean, the challenges we face are complex. They require a global network of brilliant minds working together to find solutions.
Absolutely. Take quantum computing, for example.
Right?
Developing a functional, scalable quantum computer is a monumental task.
It is.
And it demands expertise from so many different fields. Physics, engineering, computer science, mathematics. We need people from all over the world with different backgrounds, different perspectives working together to make it happen.
Exactly. No single country has a monopoly on talent or innovation. Fostering a global network of collaboration allows us to accelerate advancements and lead to breakthroughs that benefit all of humanity.
It's a good reminder that science transcends borders.
It does.
It's a universal language that can really unite us in our quest to understand the universe and harness its potential for good.
I completely agree. And just as important as collaboration is nurturing the next generation of scientists.
Yeah.
Remember, Amaldi was a dedicated teacher and mentor,
Right.
and he inspired countless students to pursue careers in physics and related fields. That kind of mentorship is essential for the future of quantum technology.
Yeah, we need to cultivate a new generation of scientists who are equipped to tackle the challenges that lie ahead.
For sure.
It all comes down to investing in education, supporting cutting-edge research, and really fostering a culture of scientific curiosity.
Those are the key ingredients
Yeah.
for a thriving quantum ecosystem.
And we can't forget about the ethical dimension of scientific progress,
Oh, absolutely.
something that Amaldi was deeply committed to.
Mm-hmm.
As we develop increasingly powerful quantum technologies, we have to consider their ethical implications.
Yes, you do.
It's a responsibility we can't shy away from.
You're right. We need to make sure that these incredible advancements benefit humanity as a whole,
For sure.
that they're used responsibly and ethically, and that they contribute to peace and progress.
That's the vision
Right.
that Edoardo Amaldi championed throughout his life.
His legacy is a powerful reminder that scientific progress should always go hand in hand with ethical considerations.
Yeah.
A deep commitment to the well-being of humanity, and a constant awareness of the broader impact of our work.
So as we wrap up our deep dive into the life and work of Edoardo Amaldi, it's clear that his story offers us so many valuable lessons for the future of quantum technology. International collaboration, nurturing young talent, upholding ethical principles. These are the guiding principles we need to embrace as we explore the vast potential of this extraordinary field.
And we must never forget the power of scientific curiosity, that thirst for knowledge that fueled Amaldi's remarkable journey and that continues to drive scientific progress today.
Thank you for joining us on this incredible exploration of Edoardo Amaldi's life and legacy. We highly recommend checking out the full essay by Jorgo Schneeppat for a more in-depth look at this remarkable physicist.
It's an inspiring read.
It is. Until next time, keep exploring, keep questioning, and keep pushing the boundaries of human understanding.